Good morning. So I hope you enjoy last night gala dinner. Absolutely fantastic, and thank you very much for being here, maybe very early for some of you. And actually, I want to use my 10 minutes in drilling down more in the energy part of what we're doing at the IEC and about smart energy and smart energy for smart cities. And I would like to use my 10 minutes actually to share with you maybe a couple of secrets, some insights, and things you cannot read anywhere regarding those standards. So just to make sure we are talking about the same thing, when we are mentioning smart energy, we consider actually the entire chain from any point of generation to any point of consumption. Okay. And that's quite interesting because this is where we are considering that flexibilities, of course, in the entire electric system, you can get some flexibility through electro-technologies. You may think of adding local generation or storage, but it's also very interesting to get flexibilities through interactions with gas and heat and preheating or pre-cooling, for example, is extremely efficient and really, really cheap. So this is why we came up with this concept of smart energy. And this is really everything about energy you might think of for a smart cities in a nutshell. But of course, as soon as you consider this entire chain from end to end, this is crossing many different domains that are organized separately today. And this is very complex technically, but this is even more complex from an organizational viewpoint. And this is where you dream about having a possibility to pre-resolve some of this complexity. And this is where, to us, the IEC, we consider that the standards are a master key to pre-resolve this extraordinary complexity. There is no system on Earth that is, industrial system on Earth that is reaching the level of complexity of what we're talking about with smart grid and smart energy for smart cities. Well, actually what the investors want, because if you want to start to deploy the system, you see, you need to have people that's going to sign a check and make a decision about choosing a technology and starting to engage in investment. What the investors want, they want to be able to purchase very large number of equipments from many different vendors. And why? It's very simple. Actually, if you would issue one RFP and contract with just the cheapest vendor, this one would get an incredible contract, and all the others would progressively die out. And we are talking here about infrastructures, critical and vital infrastructures with lifespan of 20, 40, 60 years. We're not talking about consumer electronics. So this is why you need to, whatever you do as investment, you need to think of creating an ecosystem that will be sustainable and that will actually be in the position to provide the equipments to keep up and running those 24/7 infrastructures. And this is why it's so important that to purchase and acquire very, very large number of equipment, you need to make sure that you have many people, many players at the table. And this is where people started to mention this interoperability magical concept. But interoperability means many different things. And on this graph, or on this chart, you see that there are many different levels of interoperability. And the extreme degree of interoperability is interchangeability. And I just draw your attention that in the mind of the decision makers, very often interoperability means interchangeability. And we have to be very careful, and maybe I'm taking some time here because to me it's the most important slide of my presentation. You can achieve interchangeability many different ways, the easiest way to do that is just to come up with one design, and then you issue an RFP to many different players that's going to carbon copy this design. You see, they're going to manufacture the exact same equipment, but they are just fighting and competing just as reducing the cost on the price of assembling or soldering components. But if you do that, actually the issue is that those competitors have no space to really compete, to innovate on the long run, and actually allows to bring in some innovations. And they have absolutely no room to develop themselves and no room to provide the enhancements that will be needed by the sector, by the investors on the long run to get more and more performance for lower cost. So the secret here is actually not to issue RFPs on a detailed design, but to issue an RFP at a level that will allow some freedom for competition for the players. This is a bit conceptual, I agree, but this is absolutely critical. And how to do that? This is where we have to be careful about the standards we are referencing. There are standards at the level of equipments, but now we are talking about more system standards, which will be standards that are addressing more the expected services and the expected performance from the solution. And this is where we have engaged this system approach, system thinking within the IEC, which is beyond and adding to already the very powerful equipment level standards, adding this capability to pre-resolve the complexity. How do we do that? Actually, you need to take up some highest view and talk on the concept level rather than just considering the actual implementation blueprints. And you need to articulate the discussion, because conceptual level, it's easy to agree upon, but you cannot really do anything from just the concept. But if you go to the blueprints, it's too detailed. So you need to come up at a reference architecture level, and this is where all the SDOs are investing a lot of efforts to come up to that level. There are still, in the industry, different reference architectures, but at the IEC, we are working hard to get some world convergence on those reference architecture, because this will be the key to the convergence of all the standards that are underpinning those reference architecture. And how to do that? We need to separate, it's very conceptual, but we need to separate more the way a solution is designed from what are the services and the performance expected from the solution. And I go very quickly there. We have been coming up and investing huge efforts on methodologies to approach this and characterizing the needs. And these are, we are using what we call the use case approach, and this has been developed, extensively used, and we even standardized the way to use this use case approach. And this is universal, and this is very pertinent for everything in the smart cities, especially. And of course, just as a anecdote, actually, China has been translating this IEC publication, and this has been promoted as the first national standard in China of their official legal framework for smart grid. Now, the good news is that all the standard organizations are now coming to consensus that through those approach, you can, having characterized enough the needs, now think about the standards that are necessary to support those needs. And this is very interesting, because when you look around, there are already a lot of standards that exist, but unfortunately, when you start to analyze or read those standards very carefully, There are a lot that are overlapping, and there are also major gaps that are still to be filled. And this is where we have started to manually analyze, screen existing standards, of course the IEC standards, but also standards from other organizations. And when you start to do that manually, you very quickly get a headache. And this is where we came up with something completely new, which is to say, wait a minute, we are investing a lot of effort in standard organizations, but we should not forget the poor guy on the left of this chart that is actually the one that is supposed to use the standards, you see, is the project leader or the project manager, now has to sit at the table in front of a pile of hundreds of standards and is supposed to actually comply to them. And of course, if you ask him, do you comply? You see, it's very easy. I have been project manager 30 years ago. The answer I was giving is always, of course I comply. If I don't, please show me where I don't. Okay? So, but this is not helping when you have very, very, very complex systems. It's easy to play that game, you see, with simpler solutions. So what we've done at the IEC is to say, you know what, we need to do whatever we can for this guy. And we need to make the standards easier to find, easier to understand, easier to apply, and we need to provide everything that will help to show that what is in the standard has been really applied, the compliance. And when we started to work on this, we came up very quickly to the idea that let's have the computers and the machines do the heavy lifting for the users. And for the users of the standards, but also for the people who are attempting to manage the development of the standards. And this is what we've done, and for several years. And this is unique. No other SDO has been attempting to start to develop a kind of a Google engine for standards. And this is quite unique. We are advancing fast, and there are major achievements going on. And there is already online on the IEC website a first approach that would allow, you see, looking at any area of smart grid, smart energy, and finding out immediately which standard exists and drilling down very quickly to what is pertinent to some project or some actor in a project, and very quickly finding out some specifics or some questions or things you should pay attention to. This is up and running. I am considering, so I started this actually. I came up with this concept a few years ago. It's moving ahead. All the SDOs are even interested to come in and bring their own standard content in this huge repository. But keep in mind, I said it's a Google, like a Google system, but it's not exactly this, because Google is just playing with a couple of keywords. Here, we want to play not just with the words, but with the semantics. Because the same word, the challenge with the standards, the same word is used in many different standards with a completely different meaning. And this is where it requires a huge effort. And this is where actually if you go online on the IEC website, what you see, I consider it's a mock-up, it's more a proof of concept, but now we are actually developing the fully blown up system that is the core of an international platform for convergence. And this is actually going on, and IEC is doing what it takes to make that work. Now, I want to drill down just on one area of IEC regarding the standards. It's a special area that was quite new, you see, with this concept of smart grid and smart energy, which is going beyond the meter, the electric meter. And going beyond the electric meter, this is where you start to connect the users, the consumers, and this is where IEC has been organizing some very specific effort in which actually India was really wise to very early on get involved. And this is a group called PC118, but what's interesting is entering in this area. What's the challenge? The challenge is not that there are no standards. The challenge is that there are too many. And this is really interesting because it is so cross-cutting, you see. It is so cross-cutting that you end up having to deal with the entire complexity of this smart energy system from end to end that I was mentioning at the very beginning. And actually, what is the real challenge in all the discussions we have? You see, on the left, you have the electric sector that has been the traditional investor in everything about energy, and especially the electric infrastructure. What they want, because they have made investments, they would like to push down to the edge their thinking and I would say their data models, because they have invested, and that would be the simplest and more natural, so that they could keep in control somehow of the entire chain. But of course, in the real life, you see, when you start to connect consumers, the consumers, they all have in their pocket now some smartphones or appliances. And of course, those have not been designed at all using the same concept or the same data models. And this is why they are coming up with completely different life cycles and lifespan, very cheap devices. And those are reality that we need to take into account, which means that you have to introduce some gateways somewhere. Now the real challenge is this discussion going on where you might need to have some gateways, but we should not have too many in the entire chain. Why? Because it's very tricky. When there is a problem, just say, oh, let's have a gateway that's going to resolve the problem. But that's too easy, you see. Instead of doing the cleaning, you see, you push the dust under the carpet. Because here, what's going to happen is as soon as you have one gateway that is supposedly resolving an issue, actually what happens is that when something will change on one side or the other, this poor gateway is supposed to be able to keep track of everything and be able to adapt. So that's okay for a 1 or 2 years lifespan infrastructure, not for 20, 40 years infrastructure. So this is why there are so many fights. This is why it is so critical to get involved and to be at the table for the discussion. Keep in mind the standards. You see, it's easy now. I'm doing the hard sell saying, you see, with the standards it's going to be magical. Just please look at the standards and use the standards. But actually, you get the industry, you and me, we get the standards we deserve. And we need to get involved and be at the table. Otherwise, it's done. You're going to cry. You're not at the table, you're going to cry. Now, and I will speed up just to come to a closure, but this one is important, which is that if you want to start moving forward in the kind of challenges I mentioned, one avenue is to come up with some kind of layered organization of the solution that you're designing. If it's layered, that means you have some construction bricks. And this is very interesting in terms of customer interface or demand response, for example. I'm showing here an example to illustrate the trend in which IECs engage regarding open standards and some reference model for open standards. And I want to draw your attention on, here there are two bricks at the bottom. One is the G3 PLC, which is a PLC solution that is widely used in metering and also that can be used widely for any application you may think of as smart energy and smart cities. But just sitting by it at the left side of this gray box, you have some RF brick technology, and typically the YSUN. And actually in this conference, you have the YSUN booth and you have the ST microelectronic booth, for example, supporting those technologies. So those are real, and there are a lot of players. I'm not advertising for one or the other, but you have a lot of players that actually have on hand this thinking, and that we are working hand in the hand with them on this. And I want to draw your attention on the fact that something which is not enough said is that you need to embed in your design the dependability of the solutions, because dependability is not something you can add after the fact, like cybersecurity, for example, privacy, etc. Those things, you cannot add them after the fact. This has to be by design, and at IEC, we have a whole series of standards regarding dependability. And this is very important. And keep in mind also, for decision makers, the system is secure or not secure for decision makers. It's really 0 or 100% for decision makers. But in the reality, it's 99 point and a number of nines. And the secret here is that the number of nines have to be decided up front, because you might come up with a completely different design depending on the number of nines. And if you think about this after the fact, after you start to have something working on the table in the lab, it is too late. And I can assure you that there will be a lot of failures in the very large projects. And I know what I'm talking about here because this has been all my career. I've been a forensic in my company for all the very large infrastructure projects. And I can tell you that all the big names have a lot of, I would say, hot experiences. You will never read anything on the web on this, okay? But the key is to have dependability by design. Certification and all the certification assessment is critical. Having standards is good, applying them, hopefully, but if you cannot bring the proof that the standard has been applied, well, it's a complete waste. And at the IEC, there's a uniqueness of the IEC also to have started to organize some specific schemes of certification back to the standards that are developed and managed at the IEC. And IEC is not just looking at being alone and trying to compete with the others. We are doing what we can, given what I explained earlier, to actually make sure we work with our cousins in Geneva, with the ITU and ISO, definitely, and also with IEEE to come up and share the platform and all the convergence effort that are going on. Thank you for your attention.